Hi everyone, and we are glad to welcome you on our today's DevConnect event. Our today's session will be dedicated to IFC SDK of ODA. As usually, we'll provide a brief introduction of our team, of our project status, its key points, and the key project and the most interesting project features. And after the presentation part will be over, we will end up with a live questions and answers session. So let's first of all introduce our team. They are here, our engineers from our IFC SDK team, and they will be glad to answer your questions. So please do not wait till the questions and answers session. Ask your questions in the comments to this session, and we'll prepare answers for you. The engineers are here today and will be glad to help. Be glad to deliver as much information as possible. So let's move on. And first, as I said, the introduction. The IFC project status. Let's start with it. So what we need to say, it is a part of the core package. So that means that it is available to all ODA members with no additional fee. It's not a sick project. It's available to everyone in ODA. And another important point, that we developed this project in partnership with Building Smart. That brings several advantages to the IFC community. And we do not limit ourselves to IFC support only, but support in terms of this project related formats as well. When speaking about the IFC itself, it's necessary to say that we support IFC 2x3, IFC 4x0, IFC 4x2 bridge specification, IFC 4x3 rail specification, and 4x4 tunnel specification currently in progress, but soon will be supported as well. Moving on to the IFC project team. We need to say that we are working at this project since 2018. We have 8 full-time developers working on this project. We already have a solid user base because, as I've said, this project is available to all ODA members, and we have quite strong feedback channels, including, for instance, the project that you probably know, Open IFC Viewer, and we engage you to join the group dedicated to Open IFC Viewer project on LinkedIn. So please use this code to join it, to provide your feedback, your opinion, whatever you need, you consider reasonable regarding the project. Next, what we target when we speak about the IFC project. We aim to create one solution for all related tasks. This means that the tasks solved by the IFC SDK could be mainly separated into two directions. So the first direction is the interaction with the proprietary architectural formats and through IFC, and direct working with IFC modeling, including data processing using auxiliary standards and non-standard APIs and IDEs, COBE, and so on. And both of them assume direct access to the IFC model on low level, and this kind of access is available through several APIs that we provide as part of our toolkit. So it may be a standard data access interface, so called SDAI, and specified in ISO 10303 part 24, and .NET API, which is a set of wrappers on top of C++ API. Just a moment, I'll switch to another slide that illustrates it a little bit better. Just a moment, a short technical issue, I think. Bottom. Let's try this. So here you can see the list of APIs that are available for our IFC SDK users. So as I've mentioned, it's just C++ API, ISO, SDIA API, C# wrappers above the C++, and we also support the approach that's called Common Data Access. It's the approach that is implemented for almost all format-specific SDKs in ODA, and it is a unified approach of data access when working with the ODA. So, and we've got a demo that illustrates different APIs, so we can show it here now. So as you can see, first this is C++ API, and it is also based on the remember, it's based on the laid bound approach, so you can address the elements by their names, and cannot be bound to particular say classes or method names, and just have a unified API to address elements properties by names. You can see several examples. You can address our examples. This IFC bridge example is available as in the archive, so you can address it yourself, having the possibility to see how those entities are created and which method calls with which parameters are used. Next, you can address also another approach, another API type, when you can address the particular entity instance referring to a particular scheme version. As you see here, the scheme version is number 4, OD, that is specified by OD IFC4. In the same manner, you see that we use the particular methods bound this next. You can see some other examples that illustrate the hierarchy and a set of methods available in this case. As I said, all those examples are available in the archive, so you can refer them and get a glimpse on them on your own if necessary. I think we can even scroll a little bit. Scroll forward. The general idea, I think, is clear. As you see, we address different attributes by name, this is the illustration of the SDI header that you can refer. So if you wish to operate according to this standard, you can refer this header to get a glimpse on the available methods. As I said, all the examples are available in the project, so you can address and refer them. If necessary, review them on your own desktop. This is a wrappers example, the C# wrappers. As it was mentioned, those are just wrappers about the C++. So it is possible to just use the legacy C++ code to rewrite some implementation with the C#, and that's an advantage of the wrappers. But anyway, please do not forget that in any case you will work with the underlying C++, so that the C# layer is just a facility to integrate the C++ libraries in your .NET solution. Okay, I think in general the idea is clear, and we can move on further. Okay, next, visualization, and I think that's probably one of the most attractive parts of the capabilities of the IFC SDK. When talking about geometry visualization, it's necessary to say that there may be two approaches. We can just use direct visualization through ODE graphic system, say on the screen, using the GLES2 device or any other device supported by ODE, or you can probably create your own extension or other geometry conversions if implemented. Sorry, the thing we need to say about the first approach is that you need to operate on a lower level. It is faster, but it's relatively more complex. There is another approach that allows you to operate on a higher level, and this involves the ODE Visualize toolkit, and you operate with the TV database, and this allows you to operate relatively more quickly, more efficiently, more stuff available out of the box, but there are several limitations introduced by the ODE Visualize, so it's up to you which approach to choose when talking about the geometry visualization. As I've mentioned, to sum up, there is a fast core visualization that for IFC 4x3 is related to ISO 10303 and the usage of the Visualize toolkit. The latter approach, the visualization through Visualize toolkit, is used in our Open IFC viewer. Most likely you're familiar with this, and we'll show you now a demo of Open IFC viewer to illustrate how geometry visualization through Visualize toolkit is implemented there, so in case you're not familiar. That's our Open IFC viewer interface, and in this demo we'll have this rail model, and we'll use the animation plugin that allows you to set some animation. In this case it will be moving of the camera according to alignment line. We'll set the points and the time that this animation will happen. So as you see, that's in some way, this animation in some way simulates riding through the rails in this model. There are many other extended features, but just an example of extended visualization using Visualize toolkit in Open IFC viewer. So I think that's the idea is clear. Move on further, but we're not limited to editing or to visualization only. Creation and editing capabilities are also supported, and when talking about the creation, we need to say that we are able to create all the elements in IFC with all the geometry and the properties. So we've got no limitations here. More to say about this. Initially, as you know, IFC was just an exchange format that allowed different software solutions to exchange architectural BIM or other information between each other. But in the recent times, some editing related problems appeared in front of our customers because they tried to use it more actively. I mean, the editing capabilities, for instance, remove or create or clone some semantic and geometry in the IFC model. And overall, we can say the trend that is that editing tasks inside IFC is becoming more and more often. Some people even say of using IFC as a native CAD format, and etc. So as we know that IFC product-derived projects have a rich set of connections with other instances within the model, especially the small echelon for geometrical representation subtrees. So error of such operations becomes a non-trivial challenge because it's necessary to consider all the dependencies, and we decided to implement them on the mid-level of the IFC SDK. In addition, combination of those features allowed us to get one of possible versions of so-called federated models on the IFC level when two or more models are united into a single IFC model, including units conversion and possibility of models of different versions, etc. So you understand that as soon as we have two models in one format, the idea of merging them is in one is quite reasonable. So such features of for light editing are united under the common name of model operations API and the IFC SDK, and the principal operations of model operations can be investigated using the IFC tutorial example executable that is available for you, so you can run one of the scenarios that is implemented in this. And such features for static editing of models include the possibility of interactive geometry update when deleted objects disappear from the model, existing objects are updated, new objects appear. A good example of interactive model operations in ODA is ODA Scan to Beam Viewer, which uses the IFC model as a layer for visualization and allows scan geometry to be updated in the sophisticated editing mode. So now let's show you an example of a federated model creation. I think that should be interesting, obviously. So we've got two models, one model with a terrain, as you see, some landscape, some building, and etc. Say it is a railway station, for instance, and we've got another model that shows us the road with even some detailization at a particular part, and the idea is to run merging of the railroad itself with the landscape and to get a federated model, and it is also available. So we can run this example. As you see, we've got these two models as the arguments, and our target is to get the federated model where all the units and etc. will be calculated and everything will be placed according to coordinates. So we can step through the key steps. They're highlighted. You can refer this video further on if necessary to understand the key steps of the merging procedure. As you see, both models are opened successfully, and the merging procedure is launched. Okay. Now we got this merged federated model. Please see that the size of the resulting model even larger than the two sizes of two models. Open the model in Open IFC Viewer. And as you see, we've got our railroad placed on the terrain absolutely correctly. So now we can work with this federated model according to the requested scenarios. Now let's move on further and talk about the IFC and other formats. As we mentioned already, IFC is a format that was initially intended for exchange, for the beam data exchange, and of course supporting other formats. We couldn't ignore this topic of the interoperability and exchange between different formats, different data, and we've got of course successes, and we've got something to suggest our members. So for instance, we can export IFC data to different formats such as DWG, PDF, or OBJ, and we've got scenarios how our members use this capability. For instance, sometimes the DWG based visualization is the primary one, so it is reasonable sometimes to export IFC data to WG to allow people exchange information, provide some feedback, markups, whatever. PDF is also clear. It's a widespread thing. OBJ allows easier work with the geometry itself when we export IFC geometry to OBJ. And we also have a set of exports from other formats to IFC. For instance, we can export architecture DWG models to IFC. Plain DWG export doesn't make any sense because it doesn't have any data that is reasonable in terms of IFC. NWD and RVT models can be also data from those models can be exported to IFC and for further work and further processing. And let us show also let us also show several demos regarding this. So first we will start with the demo that illustrates us export from RVT from an RVT model to IFC. We've got an example, a standalone application that allows to do this, and we can open the export result. So that's how it's working. So you can customize the RVT to IFC export procedure according to your requirements. We provide just a scenario to illustrate how this may be done, but you can customize everything you need according to your requirements, including, as far as I remember, even the mapping of the elements of RVT elements to IFC elements. So this thing is available. The projects also are available as well, as I said. One more thing is an export of the NWD model to IFC, so that's how it's looking in how the original NWD model looked like. Now we will call the export of this NWD model to IFC. Again, you can customize the settings of the export according to your requirements. The project is available, the implementation is available, so just refer it and again, if you have any questions, just do not hesitate to address them in the comments regarding the capabilities, limitations, whatever, exports, imports, visualization, and other procedures. You've got the YouTube session, you are able to ask questions. Just ask the questions as soon as they appear. So now we start the NWD to IFC export procedure. After the export is done and we receive the IFC model, as you see, it appeared. We can also visualize it and compare the results, at least visually. That is what we received for the IFC model with the current implementation. As you see, those are not just geometry primitives in IFC or some primitive elements. Those are complex elements, and what's more important, you can also customize the mapping of the NWD model elements to IFC model elements. The same as export from RVT models, export from NWD models is also a standalone solution, so you do not need any third-party components to do it. You need ODA SDKs only for this purpose. And now export to DWG, from IFC to DWG. Let us launch the IFC to DWG export procedure. We pass through all the key steps, obtain the model file name, we initialize all necessary exporter properties. Next, launch the very export procedure. Okay, now as you see, we have additional model file. Now it's a DWG model. We can visualize it as well. And that is what we received with the current implementation, we can visually compare the results, what we got as an input in IFC and the resulting DWG model. So that's it, I think, about the import and export capabilities, and we can move on further. Let's move on further and mention also an important topic as the auxiliary standards, because we've mentioned that our team and our IFC project is not limited to IFC only, but works with the auxiliary. In addition to main APIs for working with data on low level and visualization, ODA IFC SDK includes a set of libraries for processing of different aspects model data. We implemented a library for working with the released versions of BIM collaboration format, such as BCF 2.1 and BCF 3.0. We have also a library for validation against IDS requirements made on the side of customers. MVD XML is also supported on our side, and one of the recently implemented auxiliary formats is COBie, a standard which collects all reference data such as building project structure, set of building elements, or even responsible persons from an IFC file into an Excel table. So this is also supported, and for this we also have a demo. The first demo illustrates of how you can aggregate and place and export the data from IFC model to COBie. As you see, there is a set of auxiliary classes and methods for this. So on the higher level, you can refer the IFC COBie header. As I've said, similar to other projects, this is also available. And we also have some kind of implementation for this. You can also evaluate it in the OpenIFC viewer. The interface is provided, but please do not hesitate to address the viewer, and again, do not forget about the possibility to interact through the dedicated OpenIFC viewer group on LinkedIn to provide your feedback, comments, etc., or share your experience in any other way. So all this set of tabs is available. I think we can And the scenario of exporting data from IFC to COBI is also implemented in our XIFC tutorial. There are multiple scenarios implemented in this tutorial, so you can just address and evaluate all the implemented scenarios. This one creates an Excel file with the COBI data, and as I said, implementation is also available. You can refer it if necessary. I think we can move on further and show another demo. Next demo. The general idea I think is clear here. Because you can set up the export and export the necessary data as Excel. But let's move on to another demo. It's related to the BCF format and illustrates the possibility to collaborate through. The current version that is illustrated in the example is 3.0, and this allows to provide auxiliary information according to your requirements. Okay, let's move on further, and one more interesting and important topic, it is IFC files validation. And there are actually literally hundreds of files with different kinds of errors in our test files collections, and those files and those errors can be separated into two groups: syntax errors of step physical files themselves, and semantic errors that as incorrect data from the point of view of the format, or incorrect links or relationships between IFC instances, and etc. So many of these files were created earlier than 10 years ago, and when free toolkits or some other toolkits were quite popular to process IFC files, and many applications which produce those files have been already fixed and do not reproduce those mistakes, but we keep such files in the collection to ensure that we process such scenarios, and the toolkit developers of course improve the situation, but still we need to keep this in mind. On the OD IFC SDK side, we take responsibility for reading even such old-time or contemporary wrong data, and a lot of cases have been fixed for years during the process of our toolkit support, and such cases are logged during the file reading process, so can be analyzed or just shown on the screen. We also guarantee correct writing of the data from our side into the step physical files, and overall introduction, we are confident about that. The introduction of the OD IFC SDK that reduced the amount of errors in the files that now occur. This was about the syntax errors. but what to do with the semantic errors produced by various exporting applications. The huge part of the IFC SDK implementations is about different ways of semantic validation of models against rules defined within express schema for format, so-called interpretable where rules. The validation against rules invented by users themselves is also supported within IDS API of ODE IFC SDK. And here we also have examples to show you. The first one is dedicated to IDS validation. That's, as you see in the description. And a set of enumeration values. So we need to address the model validation plugin for this. And validate the alignment names according to the IDS description. Now if we modify, and call the validation again, you see the situation changed. Overall, we can address the file opening log for the necessary information. And we can call the validation again. And this time, as you see, it's a DA validation with the necessary settings enabled. And you can see this log with necessary information. Sorry, not log, the window. everything is available, as I've mentioned, in the Open IFC Viewer, so you can also try it on your site as soon as you download it. And you can refer for more detailed information, address the particular entities, particular lines in this window. Filtering of the validation results is also available, as you see, so you can address particular groups of information. And I guess we can move on further and get back to the presentation part. And we'll switch to the Open IFC Viewer itself, though it was multiple times also shown, but we'll have a dedicated blog about this. Again, we'll remind you that there is a LinkedIn group, and you can join it for providing information about your experience, your feedback, your suggestions, whatever you consider reasonable. So what it includes, in some way, Open IFC Viewer is the result of partnership between Open Design Alliance and Building Smart, and it provides you different valuable features and illustrates different valuable features of the OD SDKs themselves. For instance, professional visualization. It allows you also to see the object tree. It provides the properties panel and all this stuff. It's the result of usage of the all available OD toolkits. As it was mentioned, validation is also available in the Open IFC Viewer, so you can move on and try it. When speaking about the properties panel, for instance, they are implemented using common data access interface and the ability of opening IFC models not only from step physical file, that means the IFC extension, but from, for instance, compressed IFC zip, or from IFC XML or HDF5 as well, HDF5 representations as well. So this all is available, and it's necessary to say that a set of quite sophisticated plugins is part of the Open IFC Viewer. For instance, the tree view that allows to navigate through IFC model in a quite comfortable tree structure. Instance viewer that shows instance data in the table form with the ability of separate aspects validation for particular instance. Validation plugin, common model validation against where rules or and IDS requirements if they're present. Then the collision detection. Collision detection plugin is also a part of the Open IFC Viewer, so you can reveal collisions in the model that you loaded. Animation plugin, we mentioned this and you saw this, so you can animate the camera movement according to models. And PSD-QTO Manager, a plugin which allows to append or change property sets for objects within the IFC models. There are some others. There is, for instance, the BCF Palette, that a plugin for reviewing of the IFC model data and geometry, the one that you saw during the video, and several additional features for Open IFC Viewer are in progress of implementation. And the viewer itself is free and can be downloaded from the website, from the dedicated website of the Open IFC Viewer. Most likely you know it. So we have also a page on LinkedIn dedicated to this project, because right now it has really dozens of thousands of users providing us interesting and valuable feedback. So I think it's reasonable to try it. So, and just to show you some more capabilities available in Open IFC Viewer, let's have a couple of demos. The first one, tree viewer and instance viewer plugin, so that as mentioned represents the model in quite convenient, comfortable tree structure, allowing to navigate through it. Instance viewer plugin, as mentioned, shows instance data in the table form with the possibility to separate something, so the structure is available, and most likely it's familiar for all OpenIFC viewers, viewer users. So we can move to another demo. Probably even more interesting one. It is a, let's load the model and address another plugin. The PSD manager. As it was mentioned, this plugin allows to append or change property sets for objects within the IFC model. So for instance, as you see, we can introduce some editing. Okay, let's move to the next one. Layer manager is also the one that's worth attention, because it may facilitate work with the model quite significantly as well. Thus it will be possible to address the particular layers of the model. Okay, and let's move to the next one. The collision detection plugin that allows to reveal automatically all the collisions in the model. You can set up the properties for collision search, settings, or just call the collide all with all. So you'll have the pairs of elements, pairs of colliding elements in a table form. So next, it's possible to process the collision results, to sort out the collision results, or do whatever. But for sure, you get the full list of the collisions in the model. I think in general also it's also clear, and all this is available in OpenIFC viewer and of course in the ODE SDK, so you can reproduce the same things in your solution if you use ODE SDKs. As you see, it's also there are various possibilities for further processing of the collision results. So I think that's it about these demos, and now we are able to switch to our questions and answers session, and our team will join us, our engineers. So please provide your questions. Meanwhile, the questions, preparations, and progress, I wish to say that in a month we will have another DevConnect session, and we engage you to join us as well. We also have sent you emails, and in those emails you can address and set up individual meetings if you do not wish to discuss something in public. But for now, we'll be glad to answer you. What else I can add? That the recording of this session will be available on our YouTube channel as well. For instance, if you or your colleagues wish to watch it later on. So now let's start with the questions. And the first one is, hello, are you considering including Visual Basic.NET wrapper in the future? We'll address our team lead, I think, with this question.
Yeah, okay. Hello, everyone. Again, as about Visual Basic .NET wrappers, we do not have plans of implementation such wrappers right now. However, our .NET framework modules can be used from Visual Basic, so you can use that we have in your Visual Basic projects.
Okay, let's move on further. Can IFC SDK be used together with Drawings SDK to, for instance, create DGN lines with an inherent set of properties, much like a civil 3D alignment? Igor looks again, it's the question to you probably.
Yes, okay. No, it's needed to say that DGN isn't DVG, but okay, let's think you are talking about DWG format. So interoperability, of course, is possible, not directly. So IFC line is different class than DGN or DWG line. However, it can be converted manually, let's say, and for a kind of automation, we have modules which convert IFC to DWG and vice versa, so they can be used to process full files between formats.
Okay, the next one, based on our video demonstration, why is the federated IFC you built is much larger than some of the two input IFC files? Igor looks
much. Let me think. If a person is asking about size of IFC files, I think they the size of the resultant size of federated IFC models should be almost the same. Should be much close to the sum of sizes of two source IFC files, except probably that we don't process shared items in federated models. So if, for example, two walls have shared a matrix of translation, in federated model, they will be converted into two different transformations. If customer means that the physical size of extents of federated models, this is just one of source files on demo has small extents, and second file has large extents because it has a full length railroad. So federation will be of maximal size of extents of a maximal file. So probably this can be an answer to the question.
Okay, then next one, can we export as DXF? If not, any plan? So I think I can answer it myself. So when we export data from IFC, we export it to our ODDB database class, which can be saved to DWG or to DXF. So there is no difference on this level. So our OD copyx example from drawings archive is a good illustration of this, because it's not a point. So it's just a question of the, I would say, an argument to the save method and the implementation. So if it will be like DXF, it will be set as DXF with no difference, with no issues. So let's move on further. Is it possible to rename categories and then in batches? So looks, we need some additional information. Could you please rephrase your question and provide additional information, because otherwise there may be slight misunderstanding and thus not a very correct answer. Next question, IFC schema is very vast. Does ODE support all entities of IFC schemas? What about step? You get a looks, we need some clarifications here.
Yeah, okay, right. IFC schemas have a lot of entities, and we are trying to support as much as IFC schemas have. So, in particular, in the direction of geometry support, I'd say we support almost all entities of all formats, including IFC 4.3 and so on, including curves and railroad and other rail and road related entities.
Okay, then next question, how to load partially? And now I'm afraid about probably the wording is twiddling, but overall I think the idea is how to partially load large 3D models which are quite complicated for processing and will have a large memory footprint if we load and process them wholly. What means of processing large models do we have?
Okay, actually the IFC, a plain IFC data themselves shouldn't be so big, and the biggest part which takes memory during visualization is geometry itself. So we have to, let's say, convert IFC data into 3D bodies, which should be drawn on the screen, and such bodies take much more memory in addition to IFC model data. And for that, we don't have, let's say, interactive partial visualization, but we can visualize objects by object types. So, for example, as first step, for example, all IFC walls can be visualized. Then all IFC windows should be visualized, and so on. So this can be done in a programmatical way. So users have themselves turn on or off entities they want to show on the screen, and do it step by step. So probably this will reduce memory usage in some cases.
Okay, then next one now. Is it possible to build an IFC 2x3 model by C++ and write this model as IFC4? Does ODE layer supports IFC XML or IFC zip, XML or Express schema? So the thing is, the first question is, building an IFC 2x3 model and then saving it to IFC version 4?
Actually, IFC 2x3 and IFC 4 and IFC 4 formats are a bit different, and we do not have direct conversion between them. So they are partially compatible, but not full compatibility between them. So we don't have conversion, and I'd say that it's better to work in the format you are going to save file. ODA or IFC SDK also supports IFC XML and IFC zip files, but not XSD Express schema of IFC, because it is duplicated. Building Smart always has Express schema and the same schema into XSD format. But files and the IFC XML and the IFC zip files can be loaded using IFC SDK.
Okay, the next question. The OpenIFC viewer has a plugin tab. Does it mean that we can add custom plugins to add our own functionalities to the software?
Yes, you can if you are our customer.
Okay, moving on. So can I change, for example, IFC building element proxy to IFC pipe segment? I think it's related to what? Probably
to eight question. Yeah. Yes, actually, instances within model can be changed to any others. So this is actually the question of correctness. So you can change IFC building element proxy to IFC pipe segment, for example, but it isn't recommended to change a building element proxy to IFC Cartesian point, for example, as different semantics. This question is on side of implementer. But any entity can be changed to any other.
Okay, next one. Should we use sliding window? If yes, this then when available by default as a partial 3D visualization. It's related to, I guess, large 3D models.
No, as I said before, no interactive partial loading. So finally, all instances should be drawn in the same time. So no unloading of instances if they are outside of the screen. Actually, the format is quite strange in this case, because it has inverse attributes. If we unload some objects from memory, then we next time we will have to load them back, and we should calculate inverse attributes again, and this makes a partial visualization of directly IFC quite complicated. But as I understand, a visualized IFC model, if it was visualized into Visualize SDK database, can be shown in partial mode. So first of all, IFC file should be vectorized into Visualize SDK database, and as I remember, a partial visualization can be turned on for a Visualize SDK database. So probably this is the way, actually.
But anyway, if it is something really important, essential, please sign in for individual meeting. We will be able to invite, I think, some engineers from the Visualize team, and we'll discuss this in more details, because because to have some engineers from the Visualize team is a must-have thing, I think, here. So one more thing to mention, we are asked about the competitive solution, XBeam. There are some others. You see, first of all, I think I'll comment it myself. First of all, it's not correct or fair to provide comments regarding the competitive solutions from our side. Of course, in ODE, we are confident that our solution is better. Otherwise, we wouldn't do it, I think, and we are confident, but we have some, I would say, obvious advantages compared to the competitive solutions. First of all, our business model, that and the what's called the 100 years commitment. So our IFC project and IFC team exists for 6 years and will exist for many other years due to our business model, the structure, the funding of the project, and etc. The other large advantage is that we already have, and by the moment of creation of our IFC SDK, we had a large community of different vendors, software vendors, more than 1,000 software vendors, large software vendors, and the largest in the world probably. And all those vendors got the possibility to utilize our IFC SDK in their solutions. And now they actually do this, and the IFC models that appear in the world, they are primarily created by software solutions backed by ODE IFC SDK. This in turn introduces the following fact that if you use IFC SDK from ODE in your solution, there is a 100% guarantee that you'll not face any interoperability issues working with other IFC models, and your models created by IFC SDK from ODE will not interoperability issues when being opened on the software solutions of other members, especially if those members are ODE or if those vendors are ODE members. So that is an obvious and important advantage. Again, partnership with Building Smart and strong stream of feedback by dozens of thousands of users of Open IFC Viewer that provide the feedback, comments, share their user experience, and etc. I do not think that there are many other competitive solutions that have all those advantages. So that's briefly speaking, but comparing some particular deals that won't be, I think, fair. It should be somebody independent, I guess, to do this. But we are absolutely confident that we have strong advantages, different strong advantages compared to our other solutions. Is the RVT to IFC conversion feature included in the standard features, or does it require an optional purchase? The thing is that you need to have Beam RV SDK, because you need to read an RVT model, and basing on the information of simplifying this export procedure, you need to access the data in the RVT model, and then basing on this data create the IFC file. For this, you need two SDKs, Beam RV SDK and IFC SDK, and thus you need to have the license for Beam RV SDK. So to be able to perform a standalone RVT to IFC export solution, you need to have subscription and you need to have regular ODE membership plus additionally for additional fee membership in the Beam RV SIG project. So I hope this information is clear. Just regular membership and membership, additional membership for Beam RV. So in some way it will cost you additional fee compared just to the core package. If the model has bad face normals, can it be fixed automatically, or back face visibility forced in the viewer? That's the next question. Ingrid, can we help this?
Let me formulate. We actually avoid automatical fixations of geometry in many cases. So if faceted body comes from IFC file, we do not fix any topology errors there. However, automatical update or how we call it optimization is performed during for Boolean operations. So in some cases, bad normals can be fixed if body of object is participating into Boolean operation. But almost never it is fixed automatically. So I'd say back face visibility first. It is optional, but if you want to see incorrectly placed faces, you need to turn it on.
Okay, next question. When will the OD IFC first version going to release? It's looks there is a slight misunderstanding, because OD IFC SDK is already available for many years, and the SDK itself, Open IFC Viewer based on this SDK, so everything is available. Just join ODE as a member, and you'll get access to it, to the most recent version, or if you like to previous versions, to whatever you need. So the next question, is it possible to programmatically federate multiple IFC models into a single Revit or Navisworks file? You see, here we need to say that this question should be split into parts. For instance, we can create a federated model of multiple IFC models, and we illustrated this, but we do not have, we have limited creation capabilities, for instance, for Revit model, and thus right now using ODE SDKs it is impossible to create export from IFC to Revit, and to create an IFC to create an RVT model out of IFC models. So this is not possible for now for Revit. The same as just plain creation of Revit model is not is limited. So we can create and edit some of the Revit entities using our SDK, but not all for now. Okay, any other questions? Meanwhile, we're waiting. I wish again to engage you to set up individual meetings, because most likely you have some issues, you have some questions, you will need some clarifications, and probably not all of them are OK for public discussions. So please use the link in the email to schedule individual meetings. Again, we engage you also to join our group on LinkedIn dedicated to Open IFC Viewer and ODE LinkedIn group, to keep track on the events that we have, the news that we have. So any other questions? Let's keep a couple of minutes, probably something will appear. Just to remind you that in June we'll have also a DevConnect session dedicated to our civil project. So if you are interested in this area, please also join us, and we'll be glad to see you during this DevConnect session. So well, looks there are no additional questions, so we will wait for your feedback in the emails, probably in the comments on the LinkedIn and etc. And looks it's time to thank you and say goodbye. So thank you. We'll be waiting for the comments later on. Goodbye.
Goodbye.